Good afternoon. It seems we are a very small class today. Just 2 students. All right, exciting. Um, Let me get my screen share up. Oh, okay, she's coming. Awesome. Then we will be 3. Great. All right, I am live. I'm also recording this lesson again. No, don't worry about the all caps. That's fine. I got the idea. All right. So today we will be looking at the solutions of last week as well as the homework of the previous week. I only have one new thing that I will be showing you today, but today is more about seeing your solutions and showing you some of my solutions to the problems we did. Right, so let's get right into it. Okay, so you'll remember, I think it was 2 weeks ago. Yes, 2 weeks ago, where I assigned the homework of the 2017 round 2 Olympiad paper. So today we'll be looking at that for a bit. Okay, so for the first one, we have a secret. So I just want to quickly ask: did both of you in the class currently? Did you do the 2017 Olympiad paper? And Keen, did your sister also do it? This one, let me show you if this looks familiar. Let's see. Okay, great. You did it. All right. So how did you find question 1? Do you remember question 1? So the question stated where you have to create a secret message encryptor, basically. So you have to determine the length of the message and round up to the nearest multiple of 5, and then write out the message in rows of 5 characters. How difficult was this one for you? And welcome, Kylie. Right. Kylie, I'm looking at the solutions of 2017 round 2 today, as well as we did a practice last week of 2020 round 1. So I'll be looking at those solutions. All right. 45 lines of code, so quite difficult. All right. Did you get it working, though, in the 45 lines? Could you get it running? Great. All right. So then from there you can refactor. So refactoring your code means making it shorter, trying to find other solutions. So let me show you mine. Okay, so let's see what we have to do. So we have to determine the length and round up to the nearest multiple of 5, and then write out the message in rows of 5 characters until the message is complete. Send the message a column at a time from left to right. Right. So then our message will be TIC.A because we have to create every space as a dot. So let's see what you can do there. All right, so here's a very short solution. Okay, so first I create a variable. I create a message variable where I take the input. So this is where the user will type in, this is a coded message. All right, so there is our message. That's too many tabs. Now, this is where I check if it is in a multiple of 5. So I take the length of the message, and I use the modulus by 5. So if it does not equal 0, then it means we make a space. So a space is a dot. A space will be represented as a dot. So for each part where the message, the length of the message does not, where it is not a multiple of 5. All right. So now we create our code, an empty string, and then for I in range of 5, because we want multiples of 5, we take the message from I, and we take it in steps. You'll see here. In steps of 5. This means we take every 5th character. All right. And then we replace the space with a dot. So let's break this down. Let's do this, debug this, and we can see it line by line working. So let me take the first solution of, let me get this one. This is a coded message. All right. So we shall go, this is a coded message. All right. So what happens now? So first it takes the length of this message. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So this is not a multiple of 5. And then we add the dot to the message. All right. So let's see what happens. Okay, so there you see we add 2 dots to that message. All right. So we create our empty code, our empty line. So this is where we will start. We will start adding the message in 5 steps at a time. Sorry, I got distracted. My phone is ringing. Let me just put it away. Okay. So then you'll see here we take it in steps of 5. So we start at I. So I being 0. So we start at the T. And we take in steps of 5. So the next one will be TIC. So you'll see, so we took this one, we took that one, and we took that one. Because as you remember, in Python, when you write an index, so let me quickly show you. If I just said I, then it means we will take, if I is 0, we will just take the 0. We will take the T. If we add this, the last one will be our step. So the first one is where we start. The second one is where we end. So if we said, for example, I to 5, then it would take everything from T all the way to I. Then it would take the entire line. And the final one is the step. If this was a 1, it would just take every single character in a row. All right, so the 2 colons means it is, first one is our start, second one is our end, final one is our step. All right, I've done a few lessons on that. Okay, so let's go down. So now I being 1, so we start at the second one. So after that space, we start at the second one. As you can see there at the H, and then we take every 5th one from there. All right, and then we start at the I, and we take every 5th one from the I. And that is how we run through our message, and here is the final result. Right, as you can see here. And the evaluator was online again yesterday. That is a satisfying way of doing it. I'm very glad. Yes. You can take a look at this code, and then you can use your own code again. Try and rewrite your own code after looking at this, but don't just copy and paste this. All right. But if yours worked, that is great. If it works in the evaluator, that's great. All right. I love using the debugger to see line by line what happens with the code. It makes it a lot easier to understand. Okay, so that is our first one. Here is my solution. Second one. All right, so Polynachy. Let me just see what the message was. Recently, I've had a weird bug with my while loops, sir. Keen, what do you mean? What happens with your while loops? If you can explain to me. Oh, and for next week, the problem you mentioned to me about the evaluator timing out your execution, I spoke to Mr. Vuem about it. There might be a bug in the evaluator itself, but we will take a look at it next week properly. There might be something wrong with our code, but we suspect it's the evaluator. We'll look properly at it next week. All right. Let me carry on while you are typing your problem. All right, so the Polynachy, as we've done. Okay, wait, sorry, let me see. I would enter something as an input, and when I press enter, then it just goes to the next line. Keen, I will take a look if you can send me screenshots of what happens. All right, then you can send it to me privately on my Discord. All right, thank you. Second one. So the Polynachy. So far we've done the Fibonacci, the Tribonacci, and now the Polynachy. Okay, so you may recall the Tribonacci numbers, which you saw in round 1. So we have done it previously. So with the Fibonacci, you start with a sequence of 3 numbers, and then you add those 3 to show the new number. So with a Polynarchy, we can define the numbers ourselves. Okay, so Polynarchy sequence begins with n given initial terms. The next term of the sequence is then generated by adding the previous m term. So let's say, for example, we want to take every 3 terms, and we start with 1, 2, and 3. So then you see we go 1, 2, 3 will be our first 3 terms. And then we will add them. We will add the previous 3 terms to get the next one. So 1 plus 2 is 3, plus 3 is 6. So there you go. So now we will find the next one. So 2 plus 3 is 5, plus 6 is 11. So okay, so you see, so those equal 11, and so on and so on. Right. So this is where we create a custom pattern, basically. So let's take a look at how I created my custom pattern. So first thing I did was I created a variable called initial terms. So the initial terms is these 1, 2, 3. So let's do this first example. So my initial terms will be 1, 2, and 3. All right. So 1, 2, 3 is my initial terms. So then I input them as a string with a space. Okay, so I broke my code up into separate lines. So let's quickly run this. So I'm going to say 1, 2, 3, and I want m to be equal to 3. So then let's actually take a look at if m. Let's actually do this case study quickly. So if we start with 2, 3, 4, and we say n equals to 10. If we start with 2, 3, 4, and we say n is equal to 10, then we get 3, 3, 5, as in this example. So what we do is we start with our initial terms as a string with a space. Now I want to cast them to an integer. So I write the second line of code saying the initial terms integer. So then I create a list. I want this variable to have a list of integers. Okay, so 2, 3, and 4 will be our list of integers. So what I do is first I take my initial terms and I split them. So because this is a string, so here this is just a string with 2 spaces. But then when I split them, and if I don't give an argument in the split method, then what happens is it splits it by spaces. So then 2 will be an element in a list, 3 will be an element in the list, and 4 will be an element in the list. And then using the map function, if you remember the map function, we perform a method on every element in a list. So then the method we perform is we use a cast. So we cast every item in our list to an integer, and then we cast that to a list. So if we break it up step by step, then the final results in this initial terms int, this variable will just be a list of integers. So this is how we cast 2, 3. So this will just be 3 variables. Yes, Keen, what is your question? Right, let me give Keen a second. I just zoom in on this code so you can look at it for so long. I hope this makes sense up until this point. Right, let me just give a second. Alright, why did you not add the input into the second line as well? You can do that. I can say initial terms dot split with the input here, but I try and put the lines in separate. I want to break the program up into separate lines of code so it's easier to see. You'll see with 2020 this one here I did show. I'll get to this one later, but I did show you how to do it in a single line as well as in separate lines. Right. This just reads a bit easier. Especially when giving a class, so then every line makes a bit more sense. You can put it in one line. I just did it for readability. All right, yeah. You can. There's a lot of solutions online. I look at other people's solutions also when I do these Olympiad papers. Some people do them in about 40 lines, and you can understand each line very easily. Some people do it in a single line. Then they take a very complex problem and do it in one line. That's great when you're programming on your own. But if you're working in teams, one day, let's say you're part of a company, and you're about 5 people working on let's say Pick and Pay wants to make an app where they keep track of their stock, and there's now 5 people working on this app, and one person writes the code for a start, and the second and third person have to review that code. And if they put everything in a single line, or if they make it as short as possible, that can be it can be a lot less writing, but it will be very difficult for the other team members to understand that code. Sometimes a single line of code will be a lot more complex. You'll see in my final one here. So it's not always best to program in as few lines as possible, because sometimes it's very difficult if there's a lot of people working on something to understand what the first person did with that code. Right. But when you're programming on your own and you want to write as little code as possible, that's great. Right. There is a place and a time for both ways of doing. Right. But that's a very good question. I'm glad you asked that. Okay, so you can put it in a single line. I just want to show. All right, so then what we do is now I want to get n, right? So n is the nth term that I'm looking for. So for example, in this sequence, if I say n is 10, that means I don't care about this entire pattern. I just want the 10th term. All right. So then I give the user the chance to input n. Then I go for I in range n minus 1. Okay, I go n minus 1 because we start at 0. So the user doesn't have to know that programming is 0 based. The user doesn't have to know we start counting at 0. So if I say n is 10, then and the number here will be 10, then it means we will go until 11 actually, because we start counting at 0. We will count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is why we say n minus 1. All right. So then all I do is I take, so if you remember, this will now be a list. This will be a list of integers. So then what I do is I assign a new list of integers to this list. So I start at the second value. The second value because we want to move one right. And so the new first value will be the second value, as well as the sum of everything up until that point. So let me show you how that works. So if we have 1, 2, and 3, then the new value, so then we take this, so we have a list with just the numbers 1, 2, and 3. So now we want to move everything 1 to the right because we want to get this value. So then our new list will start at number 2. Right, so then we have 2 and 3, and then we take, so 2 and 3 will be our new start of the list, as you see here. And then for our new, the one we append at the end, it will be the sum of everything in that list until that point. So this number will then be the sum of everything in this list. So sum in Python is a neat little function that if you have a list of integers, you use the sum method, the sum function, sorry, and the sum function will just return the sum of every element in that list. All right, so that is how we get the sum, and then we carry on repeating this little algorithm until we get to the nth term. So if we say 10, then until we get to the 10th term. And then we just print the first line in this list. All right. So that is how I solved our Polynaki sequence. Right. My code will be online. As I just showed, use the debugger, take it line by line until you understand why I did what. I just renamed some variables in my code to make it a bit easier to understand in the class. All right, but the code is exactly the same. Number 3, rational order. Okay, so consider the set of all reduced rational numbers between 0 and 1, inclusive with denominators less than or equal to n. Here is the set when n is 5. So that means we want all the rational numbers between 0 and 1 with denominators less than or equal to n. So for this, so the denominator can max be 5. Right. So then we just want to see how many of these numbers there are. Okay. So given a positive integer n, your task is to write a program that calculates all the reduced rational numbers between 0 and 1, inclusive with the denominators less than or equal to n. Okay, so this is a bit of a difficult one to understand. Initially, it's a bit of a more complex problem. But let me show you what I did. All right. So in this, we start by getting n. So now let's use this example. So we said we want n to be 5. All right. So wait, where is my program now? Okay, so n. So we want n to be 5. So now we create a list, an empty list called I called it sequence, basically, just short for sequence. So now, for every number in a range from 0 to n plus 1, so then we go to 6. Why do I say n plus 1? Because if you remember, the first part of a range is inclusive. So we start with 0. But the second part, yes, thank you, Keen, we exclude. All right, so we want to count up until 5. So if n is 5, then we have to say n plus 1, so 5 plus 1, so we go to 6 because the second argument is exclusive. So it will ignore the last one, all right. And then we want to check for the denominator in the range starting at 1. So 1 up until 5. We say 5 plus 1, so 6 because exclusive. So now we check if the numerator, if the numerator, sorry, I said number, no. If the numerator is smaller than or equal to the denominator, then we append this to our sequence. All right. So what do we append? We take the numerator divided by the denominator, the numerator and the denominator. All right. So we append this to our sequence. Then we sort our sequence, right? And then we create a new list called final. Okay, so this is a check. Okay, so now so what I did here is I check in our sequence. So if the length of the final is 0, or if the absolute value, so the absolute value means it ignores any negative numbers. Okay, so then we check. If the final, so you'll see this is a list of lists. All right, so we did in our previous class, you remember, let me quickly just make a comment here. So in a list of lists, let's say list, if I create a variable called list of lists, the first part will be, you remember that game of tic-tac-toe we played? Where we have 2 columns and we can have 3 columns and 3 rows. So let me actually see if I can find that quickly. Then it will be a bit easier to explain. Lecture material, lists of lists. Yes, here it is. All right. I quickly want to show you, just so it makes a bit more sense. Let me open this PDF. So here we use a list of lists. So that means in every element in our list will have separate lists as an element. Where is this? Okay, great. Here I can show you. So for our first, so in this list, we have a row, and every row has a column. So you'll see if we enter it like this. So we have a variable called board, which is a list, but then board, for the first element, will have a list of 3 elements. For the second element, it has a list of 3 elements. And for the third element, it has a list of 3 elements. Right. So that is what I did here. Okay. So this is a list of lists. Okay. So then we check. So this minus 1e6, it is just a notation that you can use It's scientific notation basically to see if this number is larger than the biggest number possible as a Python integer. Right, so this is a bit of a difficult solution, but I do encourage you to break it down also, as we did. This question was a bit difficult, right? But then what I do is if this passes the check, then I append this value to our final. And then we do not have to check this. We can ignore that line. This is just to display all the values possible. I'll show you that now. So let's, for example, use the, let us say, is it this question? Yes, yes. So let's say n equals 4. Let me start. So n equals 4. Then we get the result of 7. Okay, so why 7? So let me show you in this line of code what I did. So here I just added this line to show what happens. Okay, so if we say n equals 4, so we have 7 numbers. Okay, so here is just my, this is just to display what happens. So I take the numerator, I add the division, and the denominator, this sep keyword. All right. So this sep keyword just means what do I want to be the separator of say every element. So I want it to be an empty string. If I remove this, we will get spaces. Let me quickly show you. If I take out that line, so currently you'll see this is our first element, our second element, our third element, but in that element there are no spaces. If I run this code again, and I say 4, you see these big spaces in between. So we use the separator keyword to add a custom separator between the elements. Okay, so if I run this again, our code will look like this. And then our end. So instead of writing everything in a new line, I just want it to be a space. So you'll see if I remove the end operator there and I say 4, then everything is in a new line, but we can also keep it like this, and then we can see how many elements there are. All right, so then we can count these. Let me put this back in, end equals with a space. All right, so this was a bit of a more difficult problem. Oops, sorry, I meant 4. All right, then you can see the amounts, 1, 2, 3, 4, 5, right, each of them where it is not 1. So 7 will be our final result there. Right, so this was a bit of a more difficult solution. But look at my code, try and break it down, and look online to see if you can find other examples of similar questions. Many of the Olympiad programming questions come from numerous amount of websites, where websites of all sorts of programming problems. It is not just for Python, it is for C++ and C# and all sorts of programming languages. So then you can search the question, and for many of them you can find people's discussions on these questions also. All right, here is my solution. Okay, so for 2020, this was last week's assignment. All right, what we did during our class time. So I see the students, some students said they struggled to finish this assignment. So let me quickly ask, I know Ernest was here last week. Keenan, Kylie, did you do the 2020 round 1 question paper? Just quickly check. But I will go through the solutions for them now. And how did you find it, if you did it? Oh, okay, you only did round 2. Okay, that is great, that is great. Okay, so Ernest said he couldn't finish the last one. All right. Yes, an hour is a bit stressful for some of these questions. You have to, if you do the Olympiad, you have to run. But otherwise, if you don't do the Olympiad, it is very good practice, even if it takes a lot longer. I think it was 3 weeks ago where we did 2016 round 2, and I took about 6 hours to complete that one. That was quite a difficult one. All right, but these are at least a bit easier than that. All right, so let's take a look at these questions. Let me see. wasn't able to do it. Busy week. No, don't worry about it. Don't worry about it. I will show you the solutions, but I encourage you to do them on your own. Okay, so let's start. How did you find, Ernest, how did you find question 1 for round 1? If you remember, let me just do a quick recap on the question. It was a farmer has chickens with 2 legs, cows 4 legs, bees 6 legs. Okay, so we want a program that, given the number of chickens, cows, and bees, will output the number of legs. Okay, so we want 3 space separated integers. Okay, how did you find this? It's quite simple. I'm glad. All right, this was quite a basic one. The biggest problem I've found that students have is with the input, getting the space separated input as 3 separate integers. Okay, so I see that's a problem some of the students have had in the past. So here is my solution, fairly simple. Okay, let me just quickly read the question for Keen and Kylie. Okay, so then the input, you have to use a 3 space separated integers. So the first one will be the number of chickens, the second one the number of cows, and the final one will be the number of bees in that order. All right, so if we say 5, so if we input 5 to 10, that will mean 5 chickens, 2 cows, 10 bees. All right, so we want the number of legs. So with the chickens, so this will be 5 times 2. This will be 2 times 4, and this will be 10 times 6. So then we just add the total. So we have 78 legs on the farm. Okay, so let me see what has... Oh, sounds easy enough. Yes. I'm very glad to hear that. So here is a fairly simple solution. So I created 3 variables called n chickens, n cows, n bees. So I assigned them all with spaces in between, using the commas, so they can be input in a single line. All right. So here I did it again in a single line, but for the for the Olympiad question, for the question they wanted to be input in a single line. All right. So then we use a split to split every input at the space. So then we have 3 separate elements in a list, and then we use the map function to cast them all to an int. So every element in this list will be an int. And what we do then, so then it assigns the first integer to n chickens, the second integer to n cows, and the third to n bees. All right. And then very straightforward, n chickens times 2, cows times 4, bees times 6. So same as with normal math, it first does all the multiplication and then adds them all together. Very straightforward, easy question 1. All right. Question 2, maybe a bit longer. Okay, so for question 2, how much wheat? So there is a row of tiles of length n. So we specify the length. All right. The tiles are alternatingly colored black and white, with the first tile being black. So we start, imagine a box. So we have first box being black, second box white, black, white, black, white, and so on and so on. All right. Now 1 grain of wheat is placed on the first tile. So we put 1 on black, 2 on the second, so 2 on white, 4 on black, 8 on white, 16 on black, 32 on white, and so on and so on. So every time we double the amount of wheat or grain. Right. So now we want to calculate the total number of grain of wheat on all black tiles. So we ignore all the white tiles. We only want the black tiles calculated. So we start at 1, then we have 2, which we ignore, then we have 4, which we count. So now we have a total of 5. All right, and so on. Okay, so let me just quickly explain this little part here. This is just for interest's sake. Doing Python, you don't have to worry about this. This is just interesting. So in other languages, other programming languages, if you give a value, so for Python, we do not assign a value type. We can just create a value and call it n. So this can be a list, a tuple, an integer, a string, a float. This can be anything. But in other programming languages, you have to assign what it is. So in C#, for example, I would say integer n equals, and then I can say is the input, for example. This is not entirely correctly how I'm writing this, but it's just so you can understand. I have to define what value this is. Or, so then if I say integer n, it can only be whole numbers. It can only be 1 or 2 or minus 20 or 1,400, whatever. It cannot be 1.50. It cannot be real numbers or anything in between 0 and 1. If we want to do that, then we have to say float or decimal. All right, so you understand. So just something interesting that you don't have to worry about too much, but I want to explain this. So what can happen if you make a data type in one of these languages, for example, just an integer? That integer can only store a set size number. I'm not sure where it can go. I think it can go up to a 32-bit integer. That means, for interest sake, it can go up just to a set. It's still a very big number, but that number has a limit. So then, what can happen if that number goes over that limit? It overflows. And here I saw a very nice example of what overflow. So let me show integer overflow. This was very interesting. This is a very nice visualization. So in your car, the older cars especially, they have these meters showing how far the car has driven. So with integer overflow, it happens very similar to what happens here. So when we get to the max number, 9999999, the moment it goes 100 meters above this, and then it overflows and it resets. So this is actually, so the numbers displayed are 000. So for a new person climbing into this car, he might think this car is brand new, but that is not true at all. The number is just so big that this measuring system cannot handle it. Alright, so this is just something interesting. So then you have to use another data type called long in Java, or C++, call it long, or Delphi, whatever, call it N64. C# also calls it long. So then you use, so then in your computer memory, you allocate a bigger space. So that means it can take a bigger number, but it uses more memory to store that number. Right, so for this, is for a 64-bit integer. So this is just something interesting that you can understand what this little block means, but you can ignore it. It is not applicable to Python. All right, just so you know. Okay, so then we do this so you can see, because for example, if you go to 41, you get a very big number because we count only the black tiles. So there's a few duplications in between that we skip. Right, so the input is n, which is the length of the row of tiles indicated as a single integer, and the output is just the total number of grains of wheat on all the black tiles, indicated as a single integer. So if we start on the first black tile, we count this, we skip the white one, we count the black one, skip the white, count the black, skip the white, count the black. Okay. So, Ernest, how did you find this question 2? Could you solve it? Did you get the correct output? Just for curiosity. Since Keen and Kylie didn't do this one yet. Right, but let me go. Alright, let's see what. Sorry, this is random, but I would use the mod operator to skip the white tiles. You can do that. Alright, that's actually a very interesting one. Right, to see if it's uneven. I like that. Alright, that's a cool solution. Yeah, you can do that. So what I did is I used a flag, alright, so a bool basically. So I first start with n, which is my input. Let me get it here. So okay, so n, which is my input. Then the first total on black squares is 0. Okay, so grains on... Okay, so this I will use to keep track of all the grains. Right. So grains on current square. So the first one is 1. Let me just see the question again. Now, 1 grain of wheat is placed on the first tile. Yeah, so we start with 1. Right. So what I did is I used a bool. So I said the first... So we are currently on the black tile, so true. So basically, if I can just explain my algorithm, is after every iteration, I just set my flag to the opposite of what it is, because if we're at black, then it's true. And then if we go to the next one, it will not be true anymore. So I set it to false, and then true, false, true, false, true, false. And if it's true, then I add the number of grains on that square to my total on black squares. So I go true, add that number, false, ignore that number. True, add that number, false, ignore that number. But after every iteration, I duplicate it. Not duplicate, I multiply it by 2, so I double it. So grains on current square, multiply equals 2. So if we start by 1, then the next one will be 2. Next one will be 4, 8, and so on. Alright. That would work just as well. Yeah. Okay, I see we have lost a class member, which is a shame. But anyway, so this is a fairly simple solution I got. No, yes, it is just us three. That's fun. Right. Let's go back to the question. All right. So as you see, you can use a modulus. That is also a cool solution. I used the bool value, which I just set to the opposite, and then in the end, I just print my total on the black squares. Right. That was. Thank you for doing the class just for us. That is the biggest pleasure. I do enjoy giving these classes. And it also helps me with my Python if I have to explain what I do to other people. If I just program my code on my own, then sometimes I can't explain why I did what I did. So this actually forces me to think, what am I doing? And is what I'm doing actually right? So we help each other. For programming, I've actually read this theory, which is very interesting. A lot of my friends are programmers at very big companies. The one guy works in the Netherlands, in Amsterdam, as a data scientist. He's also using Python. And he said when he is busy with a program and he's stuck, he doesn't know what to do, he has a little rubber ducky at his desk, at his office. And then he tells the rubber ducky what he wants to happen. And he explains to this rubber duck what he's doing, which is quite funny, and it works for him. So explaining does help me as well. Oh, Kylie, that is a shame. Right. Keen, will you just tell her what is going on in the class? Right, then can I go on to the next one? Wait, let me quickly ask. You just tell your sister. If it works, it works. Can I carry on, Kylie? Should we wait? Keen, is it possible for your sister to sit by you? We only have one question left. Let me just sit by your brother. So then we can do the last one. Just quickly run through it, and then I give the homework. I still can't hear, but carry on. All right. Either way. So for the final one, we want to order the letters. Okay, so I want you to write a program which, given a string consisting of uppercase letters, separated by a plus character, will output the string with the letters in reverse alphabetical order. So if we say Q, B, Q, Z, we want the output to be Z, Q, Q, B. So that means we order the list, and then that's a good idea. All right. I'll wait. Tell me when I can carry on. Okay, great. If you have any questions, please just stop. All right, stop me. Okay. So we want to create a program where we input numbers, uppercase letters, sorry, not numbers, uppercase letters separated by the plus sign. Then we want to output these numbers in reverse alphabetical order. So if we have QB, QZ, we want to reverse this Z, QQB. Okay. So I have two solutions here that I want to show you both. So my first one, I'm just going to explain line by line, but then I'm going to show you how to do it all in one line. And then you'll see why it's a lot more difficult to read. So first I create a variable called letters. So this will be a list. Okay, so I take the input and I split the input at the plus sign. So let's start doing this. Let me actually put in a breakpoint. Just to show you stop and rerun. Right, so we will take Q plus B plus Q plus Z. We take the first one. So, I should have said debug, I'm sorry. Q plus B plus Q plus Z. Did I do it again? What did I do? Oh, I actually have to stop there. Oops. Here we go again. Yes, okay, this is what I wanted. Sorry. Okay, so here you can see, here we have our list split at the plus sign. So what it does now is it throws away the plus sign and just give us separate letters. Okay, so you'll see all the plus signs are just ignored completely. They don't exist anymore. So in the second line, then we sort our list. So we have Q, B, Q, Z. So I want to sort them. But you'll see here, I have a second argument called reverse set to true. So this means we want to sort this from big to small. So now you'll see our list is now sorted. So it's now Z, Q, Q, B. All right. So for our final line, we have result. So result, I want to join all the letters, but using the plus symbol. So you can use a string, and then you can run the method on the string. So on the string, I use join letters. So what this does is it takes, because we have separate elements in a list. So I want to join all these elements as a single string. But instead of spaces, I want a plus symbol. So what you'll see what happens now is our result is ZQQB, and then we just print our result. And here you see in our console, as in the example, ZQQB. Okay, so this is the one solution, but we can do this very short. How do I forgot how to comment this out. How did I? Oh, there you go. All right. So this is everything in a single line. Let me just do it again, just to show. Z, Q, Z. But let's B, Q. And then we have once again Z, Q, Q, B. Right. So you'll see the readability is a bit less when we do it in a single line. It's a bit more difficult to understand, but it does the exact same thing. We start with the input and we split the input. Right. So now in this part we have a list with separate elements. We throw away the plus. Then we sort it. We sort this function, this thing we did here, in reverse. Okay, so reverse this, and then we join this, all these separate elements with a plus symbol, and then we print this. Yeah, you see exactly. So this is. I'm actually very glad you asked why I didn't do it in a single line. You see, so it makes perfect sense. You understand exactly what every bit of this code does. But if you put it in a single line, if you wrote this code, and I now have to come and I have to add new functions to this program, then I'm going to sit here for probably 20 minutes trying to figure out what did Keen do. I don't understand why. But if you did it like this, I'll be like, oh, okay, so you did this, and then you sorted, and then and then I can quickly just go in here and carry on with the program. But in this line, I might not understand what you try to do. Even if it works, it'll be very difficult in a team. If you program on your own, it's better. But also what has happened to me in the past is when I started programming, I also wanted to do it in as few lines as possible. Then I'd create like big programs. I was busy creating a cell phone game that I made for Android and iOS. And then I'd work on it for like a month. And then I took a month or two break. I went to Cape Town. I had fun. We didn't have a university. And then I got back to my app and I tried to carry on with my game. And with all these lines of code, I could not understand what I was doing. I couldn't understand what I tried do. So then it took me a few weeks just figuring out all my lines of code. Yes, exactly. So it's so it can be very difficult with the readability. More lines means better debugging. That is exactly correct. One of our lecturers at the university, also Prof. Blichnout, he gets quite angry at the students who write these very complex but very well written single lines of code. But then he says it's very difficult to read. Sometimes even if he does understand, he will take away a few marks saying it doesn't work well in a team. All right, better debugging, yes. That's a great answer. All right, so that is it for this lesson. And then no, I can't find my cursor. I'm sorry. Okay, so homework will be... Okay, so you did a 2020 round 2 already, if I'm not mistaken. Did both Key and Kylie, did both of you do them? All right. So I'll be going through the solutions next week. Kylie did not. All right. Then she's going to have to do it. Keen, you can carry on with more of the Olympiad question papers. We will be eventually doing all of them, right? So you can see if you can find some more difficult ones. We will be doing the solutions to round 2 next week. All right. That is it from me. You can try and do round 1 on your own, but I suspect round 1 will be very easy for you now. Right. And I hope you have a good weekend. Thank you so much. That is a big pleasure. Thank you for joining in on the classes. I hope you learned something now and then. Okay, but have a good weekend, and I will see you. Oh, wait, sorry. Next week, I am writing exam myself, so Mr. Vuum might present the class. But there is a possibility that we will also not be able to, so we will let you know if there won't be a class. Right. But we will keep you up to date. All right. Thank you. I do appreciate it. All right. So good luck. I hope you have a good weekend. Have fun. All right. And then I won't see you next week, but Mr. Vuum might see you next week. All right. Good luck and goodbye.